RNA, amino acid, 300% more effective, super effective. RNA is responsible for transforming genetic code from the nucleus to the ribosomes to making proteins. It controls gene expression and regulation. So when DNA is turned in, is a you have DNA which is transcribed to RNA because the DNA can't leave the nucleus of the cell. Remember that I told you that the virus is basically a virus coat. So DNA can't leave that piece, but RNA can. So it is transcribed from DNA to RNA. The RNA then leaves the nucleus, and maybe it's edited a bit, and then it's translated into a protein using a ribosome. And how I remember that, because I always would forget translate, transcribe, is DNA and RNA are kind of the same thing, very, very similar. So this transcribing, it's copying, transcribing. RNA or DNA to a protein, it's a different language. And when you move from one language to another, you have to translate. So that's how I remember it. So once someone told me that, I think it was one of my bio professors in university at Penn State, that then it clicked. So there's your tip. Okay, I got the nucleotide. They're the basis of RNA and DNA. Okay, proteins. Make sure I just have all these. Bacteria, mitosis. It's how bacteria reproduces. It's one method of reproduction, of how life reproduces. Mitochondria, as I mentioned before, the endosymbiosis. Mitochondria is believed to be once its own bacteria and was engulfed by a larger bacteria. And over time, that it must have been really good at converting energy and producing ATP. So the other bacteria was like, hey, I'm not going to kill you. I'm not going to eat you. Just stay inside my cell and you do that thing where you're really good at. I'll give you some sugar, or I'll give you some things to convert if you give me some ATP. So it did that, and then over time it lost more of its independence. So now the mitochondria can't operate outside of the cell. However, the mitochondria has its own DNA, and we can track that. And you get your mitochondrial DNA from your mother. All organisms get its mitochondrial DNA from its mother, so you can track the maternal line using mitochondrial DNA. Nucleus. I've said that before. There's a link between viruses and nucleus, we believe. Cytoplasm, filter fetus, asexual reproduction, tissue, muscles, swimming. Yeah, ooh, we got that. Ooh. Oh, okay, I just got jellyfish. Oh, I'm getting more jellyfish? Okay, that's what I'm doing. Okay, so I have 20 amino acids, so I'm buying them. Okay. I see, I forgot how this game works. Um, yeah, sponges, we talked about sponges, we talked about jellyfish are soft-body, free-swimming aquatic animals with gelatinous, umbrella-shaped bodies and long flotation tentacles. They can propel themselves through water by pulsing their bodies. Cool. Flatworm. Flatworm is the first organism with bilateral symmetry. Bilateral is, your right side is the same as your left side, which enables the beginning of the brain and internal organs. These simple creatures set the stage for invertebrates to come. Okay, I got that. I got the heart, bilateral symmetry. Cool. Oh, do I fish? I have fish. Cool. Okay. What is this? Cocoon. Fertilized eggs enable cocoons with flatworm body. Do I have cocoon? We have replaceable teeth too. Fish eggs. We have fish eggs. We have jaws. We have lungs. Oh, okay, great. Okay, three-bone ear. Also known as a middle ear, three-bone ear, the hammer, anvil, and stirrup are a set of organic levers. The text is hard to read. That regulate the perception of sound. Cool. Eggshell. Okay, cold-blooded. Let's do that one. We have tons of money for now, but the dinosaurs are like 200 billion, so they'll tap me out when I get to dinosaurs. Cold-blooded animals rely on external heat source to control their body temperature. This allows them to have metabol conservation metabolism and save energy, but can also make them vulnerable to overheating or freezing. Cold-blooded. Oh, we got pteropods. Okay, got another pteropod. Gills. Gills are respiratory organisms that allow fish to extract oxygen from the water around them. This lets them breathe underwater. Lungfish. Lungfish are freshwater fish that first became abundant in the Triassic era. That they breathe air and can survive on dry land by burrowing into the mud with their fins. Cool. We got legs. We get that Abdullah oblongata. That's the structure at the lower part of the brainstem. Controls the autonomous functions of the body, including the heartbeat, breathing, sleeping. It evolved in a fish around 50 million years ago and forms a large portion of the reptile brain. So something that we're talking about is the ear. So let's look at the ear. Ear is an organism that enables hearing. So you might know that. But the structure piece, that was new to me. So the ear consists of three parts: the outer, middle, and inner. The ear canal of the outer is separated from the air-filled trypanic cavity of the middle ear by the eardrum. Okay, the inner contains the otolith organ. It's going to tell me what that otolith is. Otolith. So lith means stone. Yeah, so it's ear stone. Yeah. It's Greek. Specifically in vertebrates, making these organs are what allows an organism, including humans, to receive linear acceleration. Yeah, so how many organisms, including plants, so plants use sugar, what's it called? It's like histoliths or something like that. Basically, it's these really grains of sugar inside a cell that are really heavy that will go to the bottom, and it'll sense where those basically lumps of sugar are, and it'll say, oh, that's the bottom, and then up is this way. So this is kind of in the same way. It's kind of doing the same thing, because when we move, the heavier objects will go backward. I'm assuming that's how it's working. Let's see. I don't know if it's telling us much. Okay. Mechanism. Whoa. Those are some big stones, some big ear stones. This is in cod, Pacific cod. That's a dime. And a dime, is like the size of a thumb, smaller. And these are the ear stones. Otolith. So it is. Wow. Okay, that's it coming out of the cod. Okay, so that's enough. We'll just leave it on this otolith and keep going with the game. We got warm-blooded. Okay, warm-blooded organisms have the ability to maintain a body temperature higher than their environments, enabling them to move to new and more diverse homes. Great.